All right, Mario 6 was a bit of a beast. We looked at adding animations and state to Mario, so he's a little bit more sophisticated now. But now we're going to get into the jumping of Mario, which is a very big piece of the puzzle with Super Mario Brothers. That's probably one of the more iconic features of Mario. And to do that, we need to add not only another animation and a state, but also the notion of gravity, which is pretty important in most platforming games. So what we're really going to be doing is adding a sort of burst of y velocity to our character, negative y velocity, which will have them going straight up into the air pretty fast. But then iteratively every frame after that, if they are in the jump state, then we need to add a y velocity, a positive y velocity back to them. And therefore we need to define gravity, the notion of gravity. And so we can sort of experiment with what that is. And also we should decide on a tile to draw our character at. And I'm thinking that probably number 3 here is good. It looks like the little preview thing is there. But that third frame makes for, I think, a pretty good jump animation. So we'll use that as we get into defining the jump. Cool. So I'm going to go ahead and open up the player here, which is where we're going to do the bulk of all of the work. Not only that, I'm going to start here and let's get a actual jump velocity off the gate defined as a constant. So I'm just going to choose 400, which is kind of an arbitrary amount. Doesn't really matter. This is kind of up to taste, really. But in tandem with this, you need to also choose an appropriate gravity amount. So we can say maybe local gravity is equal to, let's say, 8, just as a frame. Remember, this is going to apply 60 times a second. We're going to get 80, we're going to be moving at 400 frames a second, but that's quickly, actually, that needs to be higher. Let's maybe do 40 will be gravity. It'll be kind of up to taste. We'll experiment with that just a little bit. The next thing that we need to worry about too is actually creating an animation for this and a state in our self.behavior. So I'm going to go ahead and create a new animation in the animations table. I'm going to call it jumping, and we'll do an animation, which takes in our self.texture. Frames is just going to be, we chose frame 3, so frame 3 is going to be it. It's just one frame, just like the idle animation, so pretty straightforward. And the interval will just make 1, since it's just a single frame of animation. Now what we want to do too is we want to be able to get from our idle and walking state to our jumping state. So that's sort of the edge that we modeled in our diagram. So what we can do here is say, if love.keyboard is down, or was pressed rather, and I'm realizing now we actually don't have the love.keyboard.wasPressed function, so we're going to need to implement that ourselves. And that's something that's actually pretty straightforward to do, but we're going to need to go into main.lua in order to tackle this. But let's assume that there was a wasPressed function. There actually is not a wasPressed function. The only way so far that we've seen the ability to be able to press an individual key at once, just one press, is through the love.keyPressed callback written in main.lua. The only way that we've been able to test for keyboard input outside of main.lua so far has been love.keyboard.isDown, but that's only really if we're holding a button down. We don't want this to trigger multiple times. We only really want this to happen when we click initially. So what I can say, I'm going to make an else if here. If love.keyboard.wasPressed, and then, whoops, I accidentally went to the top of the file here, we'll say space. If that's the case, then we'll say self.y, dy rather, is equal to negative jump velocity. And for this reason, we're also going to need a self.dy and a self.dx. So self.dx is equal to 0 and self.dy is equal to 0. Let's go back down here. After we apply the negative jump velocity, we want to set our self.state to jumping and our self.animation to self.animations jumping, just like that. And we essentially want to do this exact same thing over where we have the walking bit here. So let's say if love.keyboard.wasPressed space, else if, and then we'll do this here, just like that. And then lastly, we want to also have a jumping behavior. Remember, this is going to be a function that we store at the key in our self.behaviors table. And so if we're jumping, it's the case that we're jumping. I want to say if love.keyboard. Well, I essentially want to take the movement code from here and bring it down here, but without triggering a change. I want to stay jumping until I hit the ground, but I do still want to be able to move in the air. This is a feature that Mario had in Super Mario Brothers, which gives you a little bit of maneuverability. So I can say if love.keyboard.isDown, and we'll say in this case A, then else if love.keyboard.isDown D, then end. And then if that is the case, we'll do self.direction should be equal to left. And self.dx is equal to negative walking speed. And now walking speed, or sorry, negative move speed. Let's do it. Go ahead and do that. And so far, we also haven't really been adding to our dx. We've just been setting our x explicitly here. What we can do is we could just do this. We could add a call at the very end to our update actually, which would be right here. And same thing for our y. So x and y is equal to self.x plus self.dx and self.dy. So I'll do self.dx and self.dy. I want to make sure too that when I set the x here, when I set the dx, I say self.dx is equal to negative move speed if I'm moving left, and self.dy, or times delta time, I should say, times delta time. Or actually, no, we're multiplying that already, so we don't need to worry about delta time here. Somewhere you need to multiply by delta time, or otherwise you will move incredibly fast. So probably make sure that it's an update like I did here, as opposed to being all up in here. You can set the velocity accordingly in your sort of where you have the behaviors listed out here. We're going to do the same exact thing here. We're going to set dx equal to positive move speed in this case. And we're going to go ahead and reform this to the same thing. So self.dx equals negative move speed, and self.dx is equal to positive move speed. Perfect. And in the jumping thing, so now we have self.dx is equal to negative move speed if we move left, and we want to do the same thing here. Self.direction is equal to right. Notice we're not doing a state transition. We're not going from jumping to walking, etc. We are just staying in jumping as long as we are pressing A and D when we're in the jumping state. Now I'm going to set self.dx equal to positive move speed here. And then one important thing that we should do is set self.dy equal to self.dy plus gravity. That's what I set it to, right? Self.gravity, or not gravity, not self.gravity, but just a constant called gravity, which we decided would be 40 pixels a second, and we can fine tune that as needed. Now, one other thing that we should do is we should transition from the jumping state to the idle or the walking state, probably the idle state just as a default, when we hit the ground. So in order to do this, we can just say if self.y is equal to self.map.tile_height. And actually, I think I have it set up here, the actual value. So if it's the case that our y is greater than or equal to this value, so I'm just going to copy this over here. This is where we initially start standing. So if it is greater than or equal to, to that amount, then, or we need to paste it in, then we'll set our self.y equal to that amount, and we will also trigger a self.dy being 0 and a transition to the idle state, as well as setting the correct animation. So self.animations of idle. Cool, or rather we could just do self.state in this case. Cool, so that's excellent. And then we've set the y velocity here, which is perfect. Let me just make sure this works perfectly well. I think that is all that we need to do. Okay, cool. So let's go ahead and run this just as a test to make sure. Let me just sanity check that I did add the jumping behavior and the jumping animation. It's set to frame 3. Let's run this. Hopefully I didn't have any. Okay, so I have a syntax error on line 54. Let's see what that is. So it looks like I forgot a then here. So do make sure you have the then, and I forgot one is here as well. So let's go ahead and add that, save it, rerun that. Was pressed. We forgot to add the was pressed functionality. So like I said before, we got sort of sidelined. There is no ability to check for whether a key was individually pressed with outside of main.lua. So we need to add this ourselves. So the way that I like to do this, you can actually add arbitrary values, tables and whatnot to existing namespaces, in this case love.keyboard. Because this is sort of where all keyboard functionality exists, we're just going to add our own functionality to it. So I'm going to say love.keyboard.keys pressed. This is going to be a table, which is going to store all the keys that were pressed during this specific frame. So love.keyboard.wasPressed is going to be an empty table because, by default, no keys have been pressed yet. And when any key does get pressed, I'm going to say love.keyboard.keys pressed at key is equal to true. And this is from the key pressed callback. Remember, this fires anytime you press a key. Now, an update I'm going to apply all of the current updates, and then I'm going to clear this table, this keyboard.keysPressed. So after the end of every update function call, that love.keyboard.keysPressed table is going to get reinitialized to an empty table. And lastly, I need to write the function love.keyboard.wasPressed, takes in a key, and we're essentially just going to return love.keyboard.keysPressed key. That'll return true or false depending on whether that key was pressed. So it'll store it for us. Let's go ahead and run. We do have Mario. Looks like we have some weird behavior here, which is he is going diagonally. This is very bizarre. Okay, let's go ahead and go back to the code here. Let's go over to the player class. And let me just look at the, looks like in the jump behavior, we might have a slight issue here. So if we go to love.keyboard.isDownA, we are applying, oh, sorry, self.x should be equal to self.x plus self.dy times, or rather, oh, no, sorry, self.dy, that's correct, actually, should be equal to self.dy plus gravity. And then what we need to do is make sure that this is updating. So self.y is equal to self.y plus self.y times delta time, not self.x. Let's try this now. If I jump, we do indeed see Mario jumping on the screen. So perfect. That looks like it's working great. That is it for the jumping update. So as we get to the next iteration, we're going to look at blocks. We're specifically going to look at the sort of the jump block that's very common with Mario when he jumps and hits something. So we're going to take a look at that. We'll look at how to actually check for collision. This is a big sort of topic in platforming. We're going to check for collision, and then when we bump into that specific tile, we're going to actually change it to a different tile to give it the appearance as if we are changing its state from having a coin to perhaps maybe not having a coin. So see you soon in Mario 8 for the block update.